I'm Becky Lunn. I'm a Professor of Civil and Environmental Engineering and I work at the University of Strathclyde in Glasgow. So I didn't start as a scientist, I started as a mathematician. I was good at maths at school, it was well taught in my school and it was what I did well at, and I decided I would go to university and read maths. I got to the end of my maths degree, I enjoyed it, but I really wanted to do something different. For me, it just didn't have a big enough impact. I wanted to go and help people and solve problems. So I moved from maths into engineering, and I was particularly interested in solving environmental problems. There are two major problems that require research in civil engineering. The first of these problems is that we have a massive amount of post-war infrastructure. It's large concrete infrastructure that originally had a design life of around 50 years. We are long past those design lives and that infrastructure is starting to degrade. And the problem with that starting to degrade is that it becomes hazardous eventually, and we need to be able to understand when that hazard occurs and repair it before it becomes dangerous. And a good example of when that fails is, for example, the bridge collapse that occurred recently in Italy. So a second major issue, and probably the biggest of them all and the most challenging, is that the methods that we currently use for construction are globally unsustainable. So around 8% of our global carbon emissions are from concrete, which is a major material that we use in infrastructure construction. And we're also not recycling the things that we build. So when we demolish things, we don't recycle that material in a sustainable way. My research, I'm trying to be inspired by nature to change the way that we do civil engineering. So I am taking microbes, so bacteria, tiny bacteria, and we're using those bacteria to precipitate minerals and to turn loose sands into rock. And if you think about the engineering properties of sand and rock, they are very different. So rock can take a load, sand is loose and can take nothing. So the way we do it, we inject bacteria. Those bacteria, they're just a natural, harmless, natural soil bacteria, and they can metabolize urea, which is the main component that you have when you pee. So we can feed them urea, and when they take that, they use it as an energy source. And in the process, if we give them some calcium, we can get calcium carbonate to precipitate. So if we inject the bacteria into sand and we give them urea and calcium carbonate, then they can turn that sand into a rock. And if you think about it, that could very much change the way that we construct. So we could construct coastal defences without needing to import large rocks or big bits of concrete. We could just turn sand into solid structures to defend the coast. I've been doing this research for a number of years, and we're now at a point where I'm being sponsored by the Royal Academy of Engineering and the construction company BAM Nuttall to take that research from the laboratory and out to the civil engineering market.